Hi there, this is Ed from Barnabas Robotics. I want to make a quick video here to show you how to make a really cool fan robot using some really low-cost parts, and that's pretty simple. And I'm also going to throw in some teaching points because I love learning and teaching while we build robots. All right, so with that, let's go ahead and get started. Here we have our fan template. If you bought a kit, this came in your kit. If not, you can download this and go ahead and print it out. So first thing you gotta do is think in your brain, what do I want my fan blade to look like? I recommend putting some different colors on here, making it a cool design because when it spins, it's gonna look super cool. So here's an example of what I did. See here, see I have these different colors here, green, blue, and red. So it's gonna look super cool. You'll see that when it actually starts moving. A tip here, you will wanna make sure to color and decorate before you cut, because if you cut it out first and then decorate, you're gonna get the table all messy, right? So you're gonna have your students or kids decorate, then we cut it out. You're gonna end up with something like this. Cool. And then we have to make the base of our robot. If you buy the kit, you'll see a cup included. This is just a 8-ounce cup, paper cup, so you could use any cup really, as long as you're able to decorate it. So some cups might have this like gloss on the outside, it might be harder to color, but that probably be okay too. But if it doesn't have the gloss, even better. So you see, I had I decorated my cup to match the fan blade. But you go crazy. Maybe you want this to look like R2-D2. Maybe you want to name your fan and write something on it. You could put your name on it. You could whatever you want to do. So take that time, have the kids make this project their own. It's a very important part in building our robots. Okay? Because remember, if you colored your project just like this, there's no other one in the entire world other than the one that you made, and that's super cool to realize. Okay. All right, so now we're decorated, and the next thing is we need to kind of assemble it. So we need, what do we need here? We need a motor. Okay, a motor is a very important part of a robot because it helps make things move. A couple things here on the motor we have here. This is the shaft. Okay, the shaft is the spinny part. That's the thing that's going to spin, and that's going to attach to our fan blade. That's going to make our fan blade turn and give us wind eventually. Another important part are these two copper leads here. Copper is the same color as a penny, something to explain to the kids. So find the two parts that look like a penny. Well, these two parts, these are what we call the copper leads. You're gonna have to hook up a battery power to these two leads so that it turns on this motor. Okay, now this is called a DC motor. Okay, there are many different types of motors that are used in robotics. This is a DC motor. I'm going to teach a little bit more about that in a second. But what we're using is a DC motor for our project. The other thing we need a battery, right? This is our battery source, our power source. Inside of the battery is electricity. In order for our project to turn on, we need to figure out how to get the electricity inside the battery out of the battery and into the motor. Now, how are we going to do that? We're going to make what's called a circuit. Okay, again, I will get into that. We're gonna have to make a circuit to turn this on. The next thing I want to do is go ahead and assemble part of our robot before we play with the electricity. Okay, so let's first look at this. Okay, so we have these two parts. We need this attached to here somehow. We also need it to be attached to the motor, and so we need to connect this first to the motor. How do we do that? Well, you could just poke a hole here, but that's not going to be great because it'll just fly off. I think it's not going to be very stable like that, and so we need what we call is a coupling, and that's our first vocab word of the day. I'm going to write it. If you look at the whiteboard in the kind of middle there, coupling. A coupling in robotics is anything that connects or couples two or more things together. So right now we want to couple this fan blade with the shaft of the motor. So there's going to be something sandwiched in between that's going to help us do that. And this is this disc here that is going to be our coupling. So you take this and we put it on the shaft here. See this hole right here? This hole matches this shaft perfectly. Now, which way do you put it in? You can put it this way or put it in this way, okay? You want to put it in so that this notch here, or this bump, is facing toward the copper leads, like this. Go ahead and push it in, okay? And if you want to get it super in there, what you do is you just push down like this on the table, push, and we're good. Now, the reason we want it in like that is that you don't want the bump on the outside, because this is eventually gonna go onto here, okay, like that. And if there's a big bump here, it's just not gonna stick very well. All right. Now, let's say you made a mistake. You know, it happens all the time. Was it over? No, it's okay. You could just pull and separate them. You know, give it a little muscle and it'll come off. Okay. So it's not the end of the world if it went in the wrong way. You can go ahead and fix that. But we want to make sure that that little bump there is facing toward the copper leads there. Cool. Now, before we put this onto here, what I want to do is put the motor onto the base here. So something like this. And we're gonna not just put it on because it's going to fly around, right? We want to stick it on using these sticky foams here that are also included in your kit. All right, so I'm going to just take one off like this. All right. Now it's sticky here, and I'm going to put it on the edge of the cup. Okay, I want to put it on the edge here because we want the motor to be on the edge. Why? Because the coupling, which is the spinny part, is going to be spinning. We don't want it. Here, we don't want it like this. You see, if you look closely on the screen here, if I go like this, it's rubbing on the edge of the cup. Okay, and I've seen this happen. You know, you'll make the robot, it's like, it's not spinning. It's not, you check the battery, it looks okay. It looks like it's connected. Well, mechanically, it's stuck on something. So this, if we turn on the motor and everything, it wouldn't spin because it's stuck. So you gotta make sure there's a gap there. You see that? So the coupling is not touching the cup. All right. Now that we know that, we can take off the other paper backing and then stick it on. And we want to make sure, here's another key, these these copper leads are sticking up because we want to connect to it. So we don't want to do that. No, because now we can't connect to our copper leads. So make sure the copper leads are up, and we make sure there's a gap there. And then we press down and we test. Yeah, it's on there. And then make sure that this thing can spin. No friction. It's not touching the cup. So we're good. Sweet. Okay. Now let's take a look at, so now that that's on there, we can put our fan on. So we take our colored beautiful fan blade and we turn it over. We take another sticky foam and we stick it right there on the back there in the middle. Take off the little backing here. So now this is sticky. And then now you put it onto your coupling because it's supposed to couple it to the motor. Just on the middle, as much as you can on the center. And we're good to go. Check that out. Nice. You could spin it, make sure it spins freely. If it doesn't, then make sure that this gap is there. That's probably what happened. Cool. So mechanically, we're basically there. Okay. Mechanically meaning the body of the robot is there, but now we need to create a circuit to get the electricity out of our battery and into the motor so it turns on. So before you do that, I'm going to do a quick lesson on circuits. Okay, so let's turn back to the whiteboard here. Okay, I am going to draw a battery. I'm going to draw a plus and a minus. Okay, all batteries going to have a plus and a minus. A plus is always the bumpy side. Okay, and then the flat side is going to be the minus. Now on this battery, it actually says plus right there, so that's convenient. I would take a look and just take that second to remind the kids that there's a plus and a minus, and if they can find which one is which. Okay. And as you're with it, when we're here, might as well just say, hey, every battery has a voltage. A voltage is basically how much power the battery has. The more voltage, then it's going to have more power. So if you look at it, and the way I like to teach is like have them look. Well, look yourself. I'm not going to tell you. If you look closely on this battery, it says 1.5 V. That stands for 1.5 volts. So I'm going to write on our drawing here 1.5 V for 1.5 volts. Okay, so we know that there's 1.5 volts of power on this thing. Now we need to get the power or the electricity that's inside this thing that has to do with the volts out into a motor. So I'm going to draw our motor. Okay, and our motor also has these copper leads. So I'm going to do these little copper leads here, right? All right, and now we need to get the electricity out. Now, when I talk about electricity, I like to tell a little story, okay? Because it's just more fun that way. Okay, let me set up here. Okay, so here's my story. So inside our battery, we said that there's electricity, and actually we like to call him Mr. Electricity, the little smiley face guy, okay? So here's the thing. If we want Mr. Electricity to come out to play, we need to make him a path. And not just any path. The path needs to go out from the plus, and it has to go all the way back through the minus. So I'm going to go ahead and draw a path for Mr. Electricity. So right now, he's not going to come out, obviously, because there's no path. But if I draw him a path from plus, keep going to this part of the motor, to this copper lead, and then another path from that back to the minus, what's going to happen? We have a full path that starts from the plus and goes back through the minus. So if that's the case, Mr. Electricity is going to be super happy, and he's going to come out, go to the copper lead here, and play inside the motor, which then will turn on the motor and make it spin, come through the other side of the motor, all the way back through the minus, and just keep going and going and going and going. Okay? And that's how we get Mr. Electricity to come out, and that's how we get the motor to turn on. And that is a circuit. So what is a circuit? A circuit is a path for electricity. That's how I like to explain. That's all it is. When you're making circuits, you're making paths for electricity. So I'm going to write the word circuit because we just made that. Now this is a special type of circuit we made. This is actually called a closed circuit. It's a closed circuit because it's a closed loop. You see that? It's a loop all the way around. Okay? If it's a closed circuit, then what happens? The motor turns on, right? Because Mr. Electricity is flying through there. He's going through the motor, having fun. Motor's moving. Now, what happens if we break the circuit like this? Check out what I did. I made an opening in there. Is this a closed circuit anymore? No. What is it? It is an open circuit. It's an opening because it has an opening. Now let's think about Mr. Electricity. Is he going to come out to play if there isn't a path that goes out through the plus and comes back all the way home? No, he doesn't want to go out because he can't get back home. So he's like, no, I'm not coming out. If he doesn't come out, does the motor turn on? Nope, it's going to be off. Okay? So open circuit means if Mr. Electricity stays home and your circuit's off. Closed circuit means that it's a full loop and it's on. And that's it. So we learned about circuits, and we learned about how we're gonna get this Mr. Electricity out, so let's do it, right? All right, so let's go ahead and do it. Now we need something. We don't have any red or black wires here, right? That's why we have this battery holder, and we're gonna put them in. The way it works is a spring here. The spring always needs to go on the flat side or the minus side of the battery. I'm gonna stick it in, and we are good. Okay. So now let's do exactly what we have on there. Well, this right now it's an open circuit, right? Because there's no path all the way from the red to the black back to the minus. So if I want to make it match exactly like what we have on my current whiteboard, let's connect the black side, because we can see in our circuit diagram that the black side is connected to the motor, but the red side is not. So the way you do this is you take this. Can you see this? Yeah. If you look at this, my wire here, this black wire, has this black protective covering. That protects the wire from touching places you don't want to touch. But the part that is conductive, or in other words, the part that you want to connect to the wire, is actually this silver exposed wire part. Okay? So if you connect just like this black part to the copper lead, that's not going to do anything. Electricity can't travel through the black thing. So you have to go and find the conductive part, and which is this exposed wire, and we're going to bend it to make like a little hook. Okay, you see that? I'll make sure you can see in the camera. There, little hook. And then we hook it on. Just checking to make sure you can see this. Hook it on, because there's a hole through the copper lead. Hook it on, maybe pinch a little bit, and then we are on there. See that? And I can kind of tug. It's still cool. So now our circuit matches exactly what we have in our drawing, right? Now if I want to do a closed circuit, all I have to do is touch the bare metal wire here on the red side to the other copper lead, and we should have success. Check it out. Awesome. It's going. All right, now if I want it to stay on, let's go ahead and make a hook on this side too. So just bend it, make it a hook, and then hook it on. There we go. And say goodbye, fan, because that's the other cool thing about this fan, is that it runs away. So it's actually a moving fan. I think it's kind of cool. All right, so I'm going to turn it off, because to make it even better, more stable, I'm going to stick this on here. So let's get our last sticky foam here. Okay, and then we're going to stick it on the back. We know how to use these now, third time, right? Make it sticky, and we stick it on the back. Boom. All right, and let's do that again. Hook on the black side, and there we go. It's a little bit more stable, and I'm feeling the wind. Man, it's really beating the Pasadena heat right now. I love it. All right, and then so now you can, now that you know, when you're finished with this project, check it out. You see that cool design? Why it's mentioned to do different colors? Because look at that. You can like really enjoy what's going on here. Things I've done with students, if you actually took a marker right now and put it right here, it would actually mark the blade as it's spinning and kind of create some really cool effect, like the colors will start moving around. I'll let you do that as a kind of I'll let you do it on your own and see what happens. It's pretty cool. Some more expansion activities. I'm going to go ahead and disconnect this. Okay. I mentioned that we're using DC motors, okay? The reason why we're using this DC motor is super easy to turn on. You just give it some electricity and it turns on. Super easy. Now here's the other thing about DC motors. DC motors can actually move in two directions. So how do you do that? Well, what happens if I flip the wires? If I put red on this side and black on that side, will it still work? Probably, because I said that we can move different directions, but let's just make sure. See, it goes different directions. Okay, now so I'd like to say it can make it DC motors can spin clockwise or counterclockwise. Now depending on what age group you're working with, they may not know what clockwise or counterclockwise is, so it might be a good opportunity to talk about that. How does a clock move? You know, let's go the same way as a clock or the other way of the clock. So you can now, based on the terms that we've learned, we can do open circuit, we can do closed circuit but clockwise, closed circuit but counterclockwise, you see? So you can reinforce what we're learning here. Last thing I want to mention is the fan blade. Oh, yes. Notice when you change the direction of the fan blade, it actually changes the direction of the wind flow. So connection to the real world, I have a ceiling fan, not in this room, but another room. And there's a feature to change the direction, the way that it turns. And it will, in one direction, it blows air down, which is really cooling. And if you change the direction, it pulls the air up, which it actually recommends to heat up the room. So it's interesting. I don't know if you knew that. The ceiling fan can help you heat up the room too by changing the direction of the air. So yeah, feel it out. Like, don't take my word for it. Try it. Change the direction of the fan flow, and then see, or the direction of the spinning blade, and see if you can feel the difference. Also, when you angle these blades, it also will give you less or more wind. Okay, has to do with aerodynamics. Okay, what else can we talk about here? And then just experiment. You know, if you have other pieces of paper or scrap paper, you probably have some scraps from the templates at the very least. Make your own blade, change it up, make a huge one. If you have extra parts, maybe there's some way you get 2 motors on there. I'm not going to tell you how to do that. You can figure it out yourself, right? Just experiment. That's kind of the joy here, is like, you know, I give you some basic tools, and then you let the kids just really explore and make it their own. Last thing I want to mention before I go, there's a third type of circuit that I haven't mentioned yet. So let me see if I can, going back to my whiteboard here, I'm going to try to erase what I need to erase. 1 second here. Okay, so what if I did this? If you're looking at the whiteboard, what if I didn't connect to the motor and I connected the battery directly like this? Or I had the red connected to the black. So you do have a closed loop, okay, from plus all the way back to minus. So Mr. Electricity will come out in this sense, in this case. But will it turn on the motor? No, because the path doesn't go through the motor, so it's not going to turn on the motor. But there's also something that will happen here. Because Mr. Electricity has such a short path, because it doesn't go through a motor, it just goes basically in and out, in and out. Basically, it's like you coming out of your house in the front and then going straight back to the back door, back to the front, back to the back door. That's what it's a very short distance. And so what happens is Mr. Electricity travels really fast, and what happens is that the battery and the wires start heating up. So that's called a short circuit. So in electronics, whenever we're playing with electricity, learning about electricity, we want to avoid the short circuit, because we don't want our products to, the parts we're using to get hot. So I'll actually show what that looks like. All right, so if we have our battery here and we make a short circuit, we'd be connecting these two together like this. Now, you would want to tell the kids to avoid it, but I'll go ahead and do that. So don't do this. Don't purposely tell the kids to do it, right? Because that's not what we're trying to do. But I just want to show you what happens. See, it doesn't look like anything's happening, right? So I'm doing it. If I held it here for a very long time, what would happen is that it would start heating up. Because we're not using extremely high power, nothing really is gonna happen, except you're gonna feel it heat up a little bit. But we want to teach also electronic safety. So make sure we say, let's avoid the short circuits, because we don't want our parts to heat up and get damaged. Okay. All right, I'm going to leave you with that. So that's the fan project. I was challenged to create just this really simple, low-cost project, so I was proud that we could, put this together. Share what you make. Find us on Instagram, Barnabas Robotics, or shoot us a or find our Facebook page or email at info@barnabasrobotics.com. We'd just love to connect and see what you guys make. If you have any comments or questions, you can feel free to leave them on the video here. And I also have a part list also on the description. All right, take it easy and be safe and have fun. Bye.